I'm Irishmi Pilagoy, and now I'm gonna make a tutorial about the decimal to binary and binary to decimal conversion.
So now, let's begin. How can we convert 75 into a binary number? It helps to be familiar with the powers of 2. 2 to the power 0 is 1. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. 2 to the sixth power is 64. 2 to the seventh power is 128. Now we don't need to go further because 128 exceeds 75. So the highest number that is highest base 2 number that is less than 75 is 64. So now we have our first number, which is 64. In this case, let's subtract 75 by 64. And so that will give us 11. Now, the highest number that's under 11 is 8. 16 exceeds 11, so we can't use that. So let's put 8 here. And then let's subtract 11 minus 8 is 3. And so the next highest number just under 3 is 2. So 3 minus 2 is 1. And so the next highest number is 1. And let's put 1 here. And we could stop here, because if you add these numbers, 64 plus 8 plus 2 plus 1 is equals to 75. Now let's begin to write the numbers in binary. So because we have a 64, we're gonna put a 1. We don't have 32, 0. We don't have 16, so 0. And we have 8, so let's put 1. And we don't have 4, let's put 0. We have a 2, so 1. And 1, let's put 1. So 75 is equal to 1001011. And this is the subtraction method on how we can convert the decimal to binary. Now the second involves successive division, and we will use our example, which is the 75 equal to the binary number 1001011. Let's confirm this using successive division. So here's what we need to do. Start with 75 and divided by 2 is 37.5. So this means is that it's 37 remainder 1. Now take the 37 and then divide that by 2. So 37 divided by 2 is 18.5. So that's 18 remainder 1. Then take the 18 divided by 2. 18 divided by 2 is exactly 9 with no remainder. So let's put remainder 0. And then 9 divided by 2 is 4.5. So we say it's remainder 1. And then 4 divided by 2 is exactly 2. So it's 2 remainder 0. And then 2 divided by 2 is 1. So 1 remainder 0. Then finally 1 divided by 2, that's basically 0.5. So we could say it's 0 remainder 1. And now we should stop here. So at the bottom, you have the MSB, most significant bit. At the top, you have the LSB, or the least significant bit. Now the way you read, it is from the most significant bit to the least significant bit. So look at the numbers now that we have. We have a 1, 0, and then 0, and then 1, 0, 1, and the last is 1. So if you write it from bottom to the top, it's 1, 0, 0, 1, 0, 1, 1. So hopefully you see that, and so that's how you can get the same answer using successive division. And now let's convert binary to decimal. So let's start with this example. 1010. How can we convert this particular binary number, which is a base to system, the digits can only be 0 or 1? How can we convert it into a decimal number? Now the first value is 2 to the 0 power, and the second one is going to be this number times 2 to the first power. And the third value, going from right to left, is 0 times 2 squared. And this one is going to be 1 times 2 to the third power. So 1 times 2 to the third power, that is equal to 2 to the third power. And then if we multiply 2 squared by 0, that's going to give us a 0. And we're gonna add these values, and it's gonna be 1 times 2 to the first power, which is just 2 to the first power. And then 0 times 0 is 0, so everywhere you see a 0, you could ignore it. So we only need to focus on the numbers that contain a 1. Now let's add up these numbers. So what is to the third power? To the third power is 2 times 2 times 2, which is 8. To the first power is simply 2. So we're gonna get 8 plus 2, and so the answer is 10. So the binary number 1010 has a value of 10. So now, what if you're given a fractional binary number? How can you convert that into a decimal number? For instance, let's say if you have the number 1, 1, 0, 0 with the decimal point, then 1, 0, 1. How can you convert that into a decimal number? So the first number best to the left of the decimal point, that's 2 to 0 as always, and then 2 to the first 2 squared, and the last one is associated with 2 to the third. What about the numbers to the right of the decimal? Well, if we follow the pattern of exponents that we see here, the number that's less than 0 is negative. So this has to be associated with 2 through negative 1, and then 2 to the negative 2, and then to the monastery. Just like before, we're going to focus on the values and that bear on 1. And so we're going to add 2 to the third plus 2 squared plus 2 plus 2 negative 1 plus 2 negative 3. So now to the third is 8, and 2 squared is 4, plus to the first power is 2, so the negative first power is 1, so it's going to be 1 of 2, plus 2 to the third is 8, so 2 to the negative third, it's going to be 1 of 8. And so 8 plus 4 is 12, and then we have 1 of 2. So let's divide 1 divided by 2, it's 0.5, plus 1 divided by 8 is equal to 0.125. So adding up these three numbers will give us this answer, 12.625. So that's how we can convert a fractional binary number into a decimal number.